Hello all, in this video we will see how to create a footprint for a component in KiCad. So we have something called footprint editor which actually helps us to create footprints. So to create footprints, click on this and it takes some time to open. Okay, so now here this is the window where we can create footprints, and you can see already all the global footprints are included here. Now for us, what we did is we included something called KiCad underscore fp dash library. So we'll also show how to create. For example, here you can say click on file, new library. Okay, and then here select global and click OK. So here go to your project, and here you can create a folder, whatever, uh, KiCad fp 1 dash library, whatever you can name as per your requirement. Okay, and we are naming it the library. Okay, so we have created a library folder, okay, in which you can save all your libraries. Now we are going to create library for the 32-bit RISC processor, which is part of our design. So here we have a microcontroller, which is a RISC-V controller schematic, which is CS32V003F4P6, which is a RISC-V microcontroller. So you can copy this, so, and then go to the data sheet of the microcontroller and search for the particular component. You can see this particular part has a package of TSSOP20. Okay, so you can, if you want, you can browse through, or you can also search for TSSOP20, and you can see here this is the TSSOP20 package dimensions, and we need to create footprint for this part. So the critical thing, the first thing in the footprint creation is checking the MPN, and corresponding footprint need to be checked. Many cases, very simple problems happen where the manufacturing part number and the footprint varies. So actually we'll consider a footprint of QFN part, and then we'll order TSSOP part. So this is a common mistake that happens in the schematic. So to eliminate that, first we have to ensure MPN versus footprint. So we have TSSOP package in our schematic, and then we are creating it the footprint. Now go to your FP1 library. Okay, and here you can see, or right click, you have two options: new footprint, create footprint. Or here also you can have, you can see the options: new footprint, create footprint. Click on new footprint, and here what we are doing is naming the footprints is one of the very important point. So you can have footprints basically created for parts, and name them customized, and also we can name them generic. Now here for this particular one, TSSOP20 is a very common package that is used. So let us make it generic. Okay, and click on OK. Okay, you see here we have ref. Okay, and we have TSSOP20 and corresponding reference. So in the ref, actually this is a IC, right? So we'll have U modified. Now the first thing is to create the pad stack. So you can see here this U is part of the fill screen. That is why this particular point is highlighted. Now how to create the pad stack? So let's go to the data sheet. You can see pad stack is nothing but the pad of that particular component. So this is the component, and you can see here this component, if you take pin 1, the width of the pin is 0.25. Okay, so that means the width of this particular component is 0.25, and then the length of the component, how do we identify, is the total dimension is 6.4 here, and the body dimension is 4.4. So 6.4 minus 4.4 is 2, and you have if you divide by half, this is 1 mm and this is 1 mm, 1 mm and 1 mm here. Okay, so comprises 6.4, which is 4.4 plus 1 plus 1, which is 6.4, right? So that means the pad length here is 1 mm and the pad width is 0.25 mm. So let us create it. So we have to go to the copper. Okay, so click on copper and then take a pad, escape. Okay, and double click on this, and what we have to do is here we want to have a rectangular pad. So if you go to the package here, this is a rectangular pad, right? There isn't any oval shaped pads, so keep it rectangular. And here what we want is the x is how much we have seen, 1 mm, right? 1 or uh, x is this one, right? 0.5. Okay, and then 1 mm. Okay, x is 1 mm here, sorry, 1, and y is 0.5, right? Now it is correct. Okay, so this is the dimension x, right? Y 0.25 mm, and this is x. So yes, you have the pad, component pad created. Now just click on this. So now we should have 10 pads, right? So one strategy here is to make it very simple. Always position it 0 0, the first pad, to have a clarity on the dimensions and easy verification. Okay, and then copy, control C, control V, and here you can copy the pad here. Okay, so now if you go back to the data sheet, the distance between center to center of the pad is 0.65 mm. So that means this pad should be at a distance of 0.65 mm. So the first thing what we have to do is, this is pad number 2. Okay, and to keep this at 0.65 mm, what we have to do is, you select the pad, right click, there will be something called positioning tools, click position relative to, and then select, and what you do is click on the pad which you want to position with respect to, and you can see here the offset is mentioned. So we wanted an offset of how much is it, 0.65, not 6.5, so 0.65, and then, oh sorry, we this is x, right? This is what most of the guys get confused. So 0 y is 0.65. Okay, you can see the distance between the pad is 0.65 mm. Okay, so 0.25, 0.65. What you can do is control C, control V. Okay, and then select both the pads. Okay, positioning tools, and select item, and you take this and click OK. Okay, so previously we selected 0.65, right? That on the x-axis. Okay, positioning tools, position relative to, and then here what you do is, this is 0, offset is 0.65 on the y side. Select item, okay, 0, 0.65, and you can see that. Okay, and only thing is, you have to change the pad number. Okay, now again control C, control V. What you can do is, okay, positioning tools, position relative to, select item, and 0.65. Awesome, right? So you rename it as 5, 6, 7, and then 8. Okay, so copy 2 more pads and select them, position them relative to the 8th item and click OK. That's it. Okay, and then rename this 9 and then 10 mm. Perfect, right? So we have the pads ready, and then now we want the pads. We created the pads on the left side 1 to 10. Now we have to create on the right side, right? So right side, if you see, uh, um, relative to this one, this is 4.4, and then this is 0.5 and 0.5. That means 5.4 will be the center to center distance. Okay, first of all copy this, okay, and try to paste it here, and what you do is select all the pad and position relative to, okay, uh, how much is it? 5.4, right? So select item, and here this is 5.4 and this is 0, and you can see now if you want you can also measure. Okay, so you can measure it. You can see this is 5.4. Perfect, right? So clear. So now the pads are ready. So this next thing what we have to do is we have to include a solder mask indicating the um, first pin. So before doing that, let us try to draw the CutYard. CutYard is nothing but the basically it indicates how much distance a component that is placed adjacent to the component should be um, having a distance, right? That means the CutYard helps us not to overlap the components in the PCB layout while placing them. Okay, in for any manufacturing purposes, the component should not be very close to the component should not be close to each other, so that we face manufacturing issues. So that is why CutYard is very important. So for the CutYard, if you scroll down here, we have something called F. Okay, so click on it and then take a line. Try to draw some line first. Okay, and then CutYard must be such a way that we have proper dimensions outlined. So we already have the uh, dimensions, and then minus 0.7, 0.7. Let us see. Okay, so the component when placed here, right, it comes almost till this point, and then this CutYard indicates how much distance it has to be uh, placed. Okay, and then this is minus 0.66 because x is the same. Okay, and then 4.9, 0.05, and 6.05. Oh, sorry, 0.66, right? We have it as 0.66, and here this is not 0.05, it is 6.05, and you can see we can extend it a little. Okay, 6.25, 6.25. Okay, and even 6.3 is fine. Okay, so and then let us try to extend this a little, because this will be till how much? It is 6, right? So 6. Okay, so now we have the component, and this can be little further as well. 6.4, 6.4. Okay, just to ensure the symmetricity. Like CutYard you can define based on your whatever guidelines you have. and then okay, so now the courtyard is defined for the component. Okay, and then we have to indicate the pin number 1 in the component. So for indicating pin number 1, again we have to go to the cell screen. Okay, and we can take this component, just try to draw something, and what you can do is we can place it little very close, 0.5. Okay, radius we can make it very less. Okay, and y need not be that much, y can be -1, and filled shape. Okay, you can see now it is placed close to the pin 1. Okay, so that means we have the pin 1 marking indicated as well. And then one more thing what we have to do is we have the component, right? So we have a courtyard that is defined, but we need to know approximately where the component sits. So to enable that, go to the component, and what we can do again here is this is again a sill screen part, so we can draw a line here. Okay, this will be approximately minus 0.66 to 6. Okay, and then minus 0.7, minus 0.7. Okay, it is exactly matching. What we can do is we can bring it little down, 0.65. Okay, still we can bring it down. Okay, 0.5, 0.5. So 0 is the component, right? So it approximately sits here, and it need not be this much length, right? So it will start with the 0.5, correct? So it will start with 0.5 and almost ends with, if we go to the component, if it starts at 0.5, 4.4, 4.9, right? 4.9. Okay, you can see this is where you can also still further bring it down, because the component will be almost till this extent, and while you don't have the exact dimension, you can also calculate if required, because this will be 6.5, right? So even that can be calculated and kept. Okay, and minus, how much is it? Sorry, 0.5, 4.9, 0.5, 4.9, and then this will be 6.5, because that's the length, right? This will be 6.5. Okay, you can bring it closer, as we know. So we have the component outline ready as well, with the pads, courtyard, and then the pin 1 indication, and then the U marking, right? You can bring this closure. Okay, and so all the things are done. So now try to save this. Okay, and you have a TSSOP 20 footprint ready for your part. So if you're a beginner, this is how much you have to struggle, and definitely there'll be confusions between x, y dimensions, and there are some guidelines for having these courtyard distances, so that you don't waste a lot of PCB space. So have your guidelines for your component, and try to create. Hope this helped. Please post if you have any questions. Thank you.